Good evening, everyone. Hope you are all doing well. Thank you for joining us today for the 33rd edition of My Webinar by Mydbops. I'm honored to be your host for this webinar, and I'm very excited to be here today. I'm immensely proud to represent a company that has been actively contributing to the open source database community, and I would like to extend my heartfelt gratitude to all of you for your continued support in our journey of contributing to open source databases. Today, we have an interesting topic to explore together: demystifying real-time analytics with TiDB. In this webinar, we will delve into the power of real-time analytics for data-driven decision making, and we will learn how TiDB unlocks the full potential of your data and how to achieve uncompromised performance with TiDB's HTAP capabilities. And we want this webinar to be as engaging and interactive as possible, so feel free to ask questions using the chat feature. And now let me introduce our presenter for today's webinar, Kabilesh PR. He is a highly knowledgeable individual with a keen interest in open source technologies, specifically MySQL and TiDB. Kabilesh is the first certified TiDB DBA in India, demonstrating his unmatched expertise in this field. And he is also an accomplished tech speaker and blogger. He has been recognized for his specialization in AWS databases, earning him the title of AWS Certified Database Specialist. He actively contributes to the AWS community as a builder and subject matter expert, making a significant impact in the field. And Kabilesh is the founding partner of Mydbops. We are excited to have him lead this event. Kabilesh, over to you.
Thanks, Annie, for the warm welcome. And let's begin our Mydbops 33rd webinar. Thanks, everyone, for coming up on a Friday evening to attend this webinar. Today's topic will be demystifying real-time analytics with TiDB. So analytics is everywhere, like whatever the application, maybe a smaller application or a larger application, wherever now the analytics is being the trend. That means how fastly to make the decision. So that is where the real-time analytics come into the picture. Let's see how TiDB in this landscape helps with the real-time analytics. Okay. So this is about myself. I have around 10 plus years of experience handling open source databases, and I started my career as a MySQL DBA, and now I'm exploring TiDB and distributed SQL solutions like Scylla, Cassandra, etc. And I'm also an active speaker and tech blogger. You can visit our website, blogs, and watch everything. And also I'm the first PingCap certified professional in India, and also have done a AWS database specialty, and I'm the founding partner of Mydbops. So to say little about Mydbops, is a service company which provides database niche services to our clients globally. And we have two modes of engagement. That is a targeted engagement, wherein it's like a consulting project where we handle your short-term engagement such as upgrade, migrations, or scope-bound activities. And we have managed services wherein our remote DBA team will assist you in your day-to-day operations. So we focus on the top open source database technologies such as MySQL, Mongo, Postgres, TiDB, and Cassandra. And also we have upcoming services in Scylla and Couchbase, etc. Okay. So this is the agenda for our today's topic. So I'll just start with an introduction of TiDB, because some might be new to this world of TiDB. We'll give some introduction about TiDB and its architecture. We'll discuss about the architecture, what are the different blocks with respect to TiDBs, and we'll discuss about the real-time analytics, what it is, and what are the difficulties in establishing a real-time analytics framework and how TiDB solves it. And from there, we'll discuss about the specialized engine, which is TiFlash with TiDB for analytical purpose, and how to enable this TiFlash, and how the queries behavior with after enabling the TiFlash. And also there is much more topic which is not covered in the agenda. We'll see in detail. Okay. So first we'll jump into the introduction. Okay. So as an introduction, TiDB is an open source distributed HTAP database compatible with MySQL protocol. I said HTAP. HTAP stands for Hybrid Transactional Analytical Processing. That means a single database can support both your OLTP and OLAP workload. So here is a snippet of the stars from the GitHub. The stars is basically depends upon the popularity of the project. So here's the snippet on the open source database stars. You can see Elasticsearch being the first, and TiDB the open source database from PingCap, is leading the way. Okay, and also the TiKV, these are all open source project. TiKV is also in separate open source project. You can use TiKV as a storage engine as well, separate storage engine as well with your other things. Okay, understanding TiDB architecture, let's discuss about the architecture in deep. Okay. So this is a TiDB architecture. You can see three different blocks like PD cluster, TiDB cluster, and storage cluster. TiDB architecture comes in a design principle of loosely coupled architecture. That means each blocks can can scale individually. That means you can scale as much as you want as per your workload and also as per your use case. Okay, let's discuss about what each block does. Okay, the first we'll discuss about the TiDB, that is a green block, which is the SQL layer. We call it as the SQL layer. This is responsible for client connections, authentication, and also this is responsible for the compatibility of MySQL. That means whatever the application which is currently talking with your MySQL can directly talk with the TiDB as well without any changes to the application code. Okay, making it easier for the adoption of TiDB in your existing infra itself. Okay. So this is the functionality of TiDB. This SQL cluster is completely stateless. That means it does not store any data. You can create as much of the that is TiDB instance or the SQL instances as per your scaling needs. Next is a PD cluster. So the PD cluster is also called as a short abbreviated as placement driver. So placement driver is a orchestrator. You can consider it as a as a manager of the cluster. So placement cluster has a global view of the cluster. That means it talks to both TiDB, that is your SQL layer, as well as the storage layer via gRPC call. And PD cluster is responsible for TSO, that is timestamp oracle, which is a cornerstone for the distributed transaction to work. And also it is responsible scheduling in the sense it will schedule the shard split, node split, and node addition. That is being handled by the PD. And also it handles the metadata. That means the information regarding which shard or which storage node is responsible for the particular data which is being requested is handled by the PD. And this all these three blocks communicate with each other with a gRPC protocol, which is a very fastest protocol. Here comes the actual storage layer. So actual data is stored in your TiKV. So TiKV is a key value pair storage. It is built on top of RocksDB. This is row based and it is transactional. This offers a high availability by forming a raft group within a smaller data chunk. We'll discuss this later. This TiKV can handle by default, TiKV has a replication factor of 3. That means minimalistically we need 3 nodes to get function, and also it can scale horizontally as per your need. That means there is no limitation on the node structure. You can add as much as node as you need, and it can scale beyond the petabyte as well. So these are the advantages of TiDB. So when you move towards TiDB, automatically you get these advantages. So first is the open source. This is completely open source, 100% no vendor lock-in. That means you are free to use it, edit it, and redistribute it. And it is horizontally scalable. That means it provides a transparent auto sharding feature. And also you can add the nodes horizontally. Okay. And also next, coming to the high availability part, it is highly available by default. That means your data is made available 3 copies by default in a basic cluster, and also it is a self-balancing and self-healing cluster. If there is a failure with a particular, it can withstand the failures of certain amount of node, and also when the node comes back online or you are adding a new node, it auto heals or self-balance itself and also distribute the load among the available nodes. Okay, and this is, as we discussed earlier, this is highly compatible with MySQL, and it is easy to adapt, and migration is also very simple. This is multi-cloud platform. That means wherever you have your data, your cloud, it can run, whether it's an Amazon, Google Cloud, or Kubernetes, anywhere you can deploy this TiDB cluster. It supports mixed workloads. That is, it is HTAP, as we discussed, hybrid analytical and transactional processing, both OLTP and OLAP. It can support in a single cluster, and it has a robust security. That means It supports the enterprise, that means the industry standard encryption features such as on the disk encryption, on the flight with SSL, and etc. Now, let's see about that. This is a global client base of TiDB, the early adopters of TiDB. Globally, there are more than 3,000 plus customers which are being using TiDB. You can see in India, Flipkart being the most user, that means most pronounced user. Flipkart, as it is a e-commerce website, Zomato again on the e-commerce as well as delivery, logistics. And also you can see a mix of customers. PayPay is on payment gateway, Ninjavan is on logistics, and this covers almost all the use cases in the industry. And having said that, TiDB can scale for your use case as well. Now let's discuss about real-time analytics. What is real-time analytics and what are the difficulties we face while setting up the real-time analytics? Let me start with a small intro on real-time analytics. So real-time analytics is what the industry is moving towards. Is a process of analyzing the data as it is created, and decisions are made promptly. That means when the data is created, the decision is made immediately with the data which is being ingested. So that is the power of real-time analytics. There are much more different types of analytics available, like historical analytics for forecasting and those things. But real-time analytics is getting traction. So I'll discuss some of the use cases with real-time analytics. For example, if real-time fraud detection, for example, on a gaming site or in a banking sector or a fintech sector, you might see that if you make 3 or 4 transactions immediately on the fly, that means within a short span of time, you might get a notification that this is unusual behavior. So that is where the real-time analytics come into the picture. And also it is used for market analysis for the share trending, and you can provide recommendations. It is good to invest on this share, this might go up or down. So that is based upon real-time analytics. And personalized recommendation. For example, if you're on an e-commerce site like Flipkart, Amazon, wherever you go, so they provide a personalized recommendation based on your shopping history and your order history, etc. And also demand forecasting and also in inventory management, like the level at which the particular product is moving and those things. So these are some of the use cases, and this also you getting vast variety of use cases as well. So now let's discuss about what are the challenges we face with respect to the real-time analytics. So as we say, real-time analytics gets you decision, but what happens behind the scene? So the challenges with the real-time analytics is the data volume and velocity. That means with huge volume of data has to be collected, and it has to be processed in a very short span of time. So that thing is very costly. That means you have to maintain the infra. Again, that with the infra that comes a cost. Okay. Again, next part is the integration part. Okay. For example, you have an OLTP system from which the data has to be pushed to an OLAP system through the pipelines like Kafka, and they also maintain Kafka. Then other integration like CDC has to be maintained, and also the data quality. So the consistency of the data. So how fast the data is being ingested onto your columns too. So these are the challenges with respect to the real-time analytics currently. Now let's discuss how TiDB solves this. Okay. So it's all about agility, and here is a simple design for a traditional system as well as with TiDB. As you can see on the side, you have a relational and you have your ETL pipelines. The pipelines may be dependent upon like a CDC getting your data from MySQL, and it is being returned to a Kafka. From the Kafka, it is going to columnar storage such as a Redshift or some other storage, and it is being powered by the ETL. So the integration, right? It takes a lot of effort in setting up these integration pipelines, and also the effort in maintaining. For example, if there is a delay in the dashboard, you might have to check multiple places, like right from the binlogs or the CDC pipeline, Kafka, and again the columnar storage. So you have to, the maintenance and development or the creation of this kind of pipelines is very costly. It might take even months for a team, and continuous maintenance is very difficult. So on the other hand, if you see here, so you have TiDB, which is HTAP database, which supports both OLTP and OLAP within a single cluster, and it can scale indefinitely and also the replication is very low cost. We'll discuss that. And you can power your real-time analytics in very real time. You can see here. Okay, so now let's discuss about how this real-time analytics is achieved by TiDB. Okay, so the real-time analytical engine in TiDB is called TiFlash. Okay, as the name suggests, it's very faster with analytical workload. So TiFlash is a columnar storage engine built exclusively for analytical workload. So if you have this, it's not only support analytical, it also can support your ongoing workloads. We'll discuss how this, we'll discuss when the query part comes, how the query is being handled. It is tightly integrated with KV. That means you need TiKV instance to create a TiFlash because it syncs the data from the TiKV. And this TiFlash is built on top of ClickHouse. ClickHouse is a famous open source project for analytical, and it is very fast with parallel processing. The same is supported by the TiFlash as well. Okay, here you see the architectural diagram with TiFlash. You can see we have a top of TiDB, that is your SQL layer, and we have 4 TiKV nodes with data for tables like sales. So the yellow box right here suggests a region. So region is the smallest unit forming a raft group. Okay, so you can see here it is connected via raft. The same raft is used for data replication. Okay, so and TiFlash is in columnar storage. You can see here. Okay, so this is the architecture with raft. Data sync with TiFlash, just now we discussed, we'll explain it again. Okay, so this is how the data is getting replicated from TiKV to the TiFlash in near real time with the replicated log groups with raft. So it uses a raft learner algorithm to get the data into its columnar store with the same, it is an extension from the same raft group of TiKV. So the replication lag is very minimal, or you can say it is very in real time. Okay, and also as you can say, you might have a question, as it is syncing from TiKV, if there is a failure with TiFlash, will it affect the production cluster? No, definitely not, because this learner algorithm will not participate in any of the elections, so that the failures on the TiFlash part is ignored. That means even if there is a failure or TiFlash is like node is down, it will not affect your production cluster. It can continue to work. So how to enable the TiFlash? So adding a TiFlash node is online. That means it won't impact your cluster. So you can add TiFlash while you're creating the cluster with your topology file. It's pretty simple. You can create it. So here I have covered for example, you have an existing TiDB cluster is running, and you got a request to have the analytical workload enabled. That means TiFlash enabled. You can enable it by as below. You can add a TiFlash server host, and then you can just scale out the existing cluster to just add it. Okay, so after adding the TiFlash, the replication won't start by default. That means you will not have a replication begin. That means you have like 20 TB of data. It won't get started immediately. So you have to, it provides a granular control at a table level and also at database level. That means you can control the granularity. You might need like 5 or 6 tables in analytical processing. You can just alter the table, what are the tables, and set the TiFlash replica to count to minimum starts from 1. If it is 0, it is deleted. So start from 1, it will automatically sync the data from the existing TiKV for this particular table in the TiFlash. And also you can set it at a database level with the alter database name. That means all the tables within that will get replicated. And also you can monitor the replication of TiFlash and other functionalities with this below table under information schema TiFlash underscore replica. Next is scaling TiFlash. So for example, your need increases and the dependency of analytical increase, and you want to add further nodes. You can add it with the same command, like you can scale out, and also with the same host file. That means YAML file, you can add the number of hosts and you can scale out your cluster, tie up cluster, scale out your cluster name and this file. It will automatically add the nodes. Adding the node is also online. It won't impact your cluster. And also you can adjust your replica count accordingly. And also you can add furthermore tables as well. To remove a particular node, means you don't want TiFlash, you can set the replica count to 0 with the same thing, and you can scale in your cluster. by removing the particular type flash node. And also you can monitor the replication with the table we said, right? Information schema type flash underscore replica, and monitor it. Okay. So how the queries, I discussed how the queries behavior with type flash. Okay. As it is being a columnar storage. So for example, here is a smart selection. There's a feature called smart selection. It automatically selects or swaps between the, it's not swaps, it uses the TiKV as well as type flash for the use cases based upon the cost estimation of the optimizer. For example, here is an example for smart selection. You have a query, that means you can see the select average price by sales start. It is a mix of workload. That means in a single query, you have both the pointed workload as well as the analytical workload, that is a table scan. So what TiDB does is, based upon the optimizer chooses to use TiKV for your pointed query for the batch ID, and it uses a type flash if the type flash replica is enabled for this particular table within the same query, and aggregate and send back your result. So this does not require any manual intervention. This is automated. Okay. So next is engine isolation. That means you can define the granularity of usage of the replicas. That means RAID replicas. This is a config file. You can define it in the TiDB configuration file. That is your SQL layer. So TiKV, this defines a replica for the TiKV in a royalty workload. So this TiDB defines your catchy table, the feature with TiDB, and also you can define the type flash by which the queries will automatically choose for its read workload accordingly. This can be also set at the session level by this. Thereby, you can start using this type flash. And obviously, there is also a manual hint option. Thereby, with a particular query, you can provide a hint like read from storage, type flash, and the table name. You can read directly from the type flash, bypassing all the optimizer and those things. What are the type flash modes? I think we have almost reached the end. So there are two modes of operation with the type flash. That is, we discussed, right, MPP, and there is one more called flash fast scan. Okay, so what is MPP? MPP is massively parallel processing. That means when you have multiple type flash nodes, the workload which you give to the type flash is being segregated. That means spread among the type flash nodes, and they each execute a chunk of data as per the plan and send back the result. Okay, so this is the block diagram. So when MPP is enabled, okay, this is enabled by default, and you have two controlling variables, that is TiDB allow MPP. That means you can switch it off or switch it on. By default, it is on. And TiDB enforce MPP. This is by default off. That means enforcing. It is compelling to use MPP all the time. But if it is off, the optimizer will take the decision. If it is on, you can switch it on and check these variables. And this is how with MPP, your TiDB will act as a coordinator to get all the result from all the type flash node and give it back to your client. So again, the last mode is a fast scan mode. With the fast scan mode, TiDB provides efficient query performance. That means the query result will be very faster, but on the other side, the caveat is that it will sacrifice the consistency. It sacrifices the consistency. That means the query result might include a history of data. I say history of data because, so for example, you might have deleted the previous data, like GC, that is garbage collected data. Like you can see for a particular primary key, you can see an older version of the same. So that is how, that is a caveat with respect to the fast scan. So you can also enable and disable type flash using fast scans by using the type flash and fast scan variables. So that way we have reached the end of our slides. Thank you for attending. And if you have any questions, you can put it on the comment section. I'm ready to answer anything. Thank you.
Thank you, Kamlesh, for delivering such an insightful presentation. So in this webinar, we explored TiDB, a powerful open source database for real-time analytics. Kamlesh showed us how TiFlash, its analytical engine, unlocks faster insights from your data. He also covered enabling and scaling TiFlash for optimal performance. We hope we addressed the questions you raised in the chat, and any questions that are not answered during this webinar will be collected and addressed in a future blog post. So stay tuned for more valuable insights and answers to your queries. And if you have any queries or would like to continue the conversation further, feel free to reach out to us at info@mydbops.com. And please don't forget to send out a review of this webinar on LinkedIn, Meetup page, Twitter, Insta, and other social media platforms for supporting MyDBOps open source activities. Once again, thank you Kabilesh PR for your informative presentation, and to our attendees, we appreciate your participation and look forward to seeing you in our future webinars. Have a great weekend. Thank you.